Alright, let's take a look at this first logarithmic function homework. So LF 1.1. So once again, my program isn't letting me take pictures or take the screenshots, so I've pretty much got to take a picture, which isn't cool. So we're graphing these, and there we go. They want us to graph over the domain of -4 is less than or equal to x is less than or equal to 4. So basically from -4 to +4, that's what they want, where they want our graph to go. Okay, so probably the best way to do this is to just make tables of values. Okay, so just write right here, and probably go -4, 0, hold on, -3, -2, -1, 0, 1, 2, 3, and 4. Okay, so 2 to the -4, remember that's like 1 over 2 to the 4th. Well, what's 2 to the 4th? That's 2 times 2 times 2 times 2. So that's 4, 8, 16. So it's 1/16. Really small number. So we start out here pretty low. Okay, then we do it 2 to the -3, which hopefully you can see. When we do 2 to the -3, you've got a similar thing going on. That's really 1 over 2 to the 3rd, which is 2 times 2 times 2. So that's 4, that's 8. So 1/8. 1/8 is going to be slightly higher. Oops, that wasn't higher, that was lower. Okay. Then you're going to do it for 1/2. And actually my dots probably need to be put lower even, don't they? It's hard for me to do it with a stylus on this. It's a little better. So then we go, so that was 1/16, 1/8. Now 2 to the -2 would give us 1 over 2 squared, which is 4, so 1/4, which is 0.25, so that's a quarter of the way up. Let's try to get, what did I just do? How did I get rid of both of them? What? That's crazy. Alright. Boom, boom, boom. There we go. Now -1, 2 to the -1, well, that'd be 1 over 2 to the 1st, which is just 1/2, or 0.5. So 1/2, close enough. Then 2 to the 0, remember anything to the 0 is 1, so that's 1. Okay. Then 2 to the 1st power is just 2. 2 squared is just 4. 2 cubed is 8. And 2 to the 4th is 16. So I'd go 1 up to 2 up to 4, 3 up to 8, and 4 up to 16. So there's the graph they wanted me to do. Okay? So then you do the same thing to number 2. And basically the only difference is you just then multiply by 2 for everything. Okay, we had that table, right? We had 1/16, 1/8, 1/4, 1/2, 1, and then back the other way. 2, 4, 8, 16. Well, notice that this one is 2 times 2x. So it's that same 2x, we're just timesing it by 2. So 1/16 times 2 would actually be 1/8. 1/8 times 2 would be 1/4. 1/4 times 2 would be 1/2. 1/2 times 2 would be 1. 1 times 2 would be 2. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. Whoops. Sorry. And so on. So this is basically the same looking graph. The difference is, we'd start out up -4 on 1/8, then 1/4, then 1/2, then 1, then 2, then 1/4, 2, 8, 3, 16, and then 4/32 would be clear up there. So it'd go like that. Okay. So then look at number 5. It says compare graph number 1 and number 2. Multiplying by 2 should generate a dilation of the graph, but the graph looks like it has been translated vertically. How do you explain that? Okay. So translating vertically would be basically saying that we took each of these dots and we moved it up slightly. Maybe it'd be easier if I do it on the same page. Same graph anyway. Okay. So how do you explain that? Well, the trick is it has to do with that aspect of doubling it. Okay, we doubled it, so we're basically doubling each one of those lines. Okay, so look, this one was only 2, this one's 4, this one was 4, 8, 8, 16. Okay, now for 3 and 4 you do the same exact stuff. The only difference is you're doing it with 1/2, and use a calculator if you need to. And hopefully you remember that when you make it the fraction like that, it's really just kind of go in the opposite direction. But just type in 1/2 to the -2, see what you get, graph those points, and then take a look at question 6. Okay, you do it the same exact way. I want you guys to try to work on that one. Okay, now 7 through 10 are dealing with what we did in class, where we are arranging them from smallest to largest. Okay, without using a calculator. This time we don't want you using a calculator. So you're gonna have to make a number line, right? And remember, we can switch it, right? B to the x equals n, and the way we translate that is the log of base b of n equals x. So on this first one, log base 2 of 32, that would be like 2 to the x is equal to 32. Well, what is x? B would be 7 to the x equals 343. C would be 35 to the x equals 1. D would be 15 to the x equals 225. And E would be 11 to the x equals 11. Okay, so then 2 to what power is equal to 32? Well, that would be 2 to the 5th. So x would equal 5. 7 to what power is 343? Well, that's 7 to the 3rd. Okay, and you try to do these without using a calculator. So like this one, you'd go 7 times 7 is 49, that's 7 squared. Times 7, well, what's 7 times this? It's 3, 6, 7 times 4 is 28, plus 6 is 34. Okay, so I know that it's 7 to the 3rd. Then, 35 to what power is 1? Well, that one has to be 0, because anything to the 0 is 1. 15 to what power is 225? That's 15 squared, so x equals 2. And 11, x would equal 1. It's the only way we can keep the same number. So we'd have 0, 1, 2, 3, 4, and so on. So 5 here would be A, 3 would be B, 0 would be C, 2 D, and 1 E. And then just talk about how by showing this work, that's pretty much your explanation. So I want you guys to try 8, 9, and 10 on your own, same like we did in class. Okay, now 12 through 16. So these ones I want you guys to try on your own without looking at me. We'll probably talk about them in class. Okay? And tell me what we can try to come up with. Okay? And we'll talk about them in class. Alright, now the other part of it was doing some more kind of review, I guess, practicing inverses to find the inverse. So, if we're looking at, let's do a couple of these just to remind you. We'll do question number 2. And how about question number 6 and 7. Then we'll do 1, 4, and go from there. So let's scoot some room, and I'll just mess up my circles, won't I? Okay, so let's take a look at number 2. So remember, think of that f of x as y. Okay, same thing. So y equals negative 1/2 x minus 2. The trick to finding the inverse, taking the x and the y, swapping them, so we get x equals negative 1/2 y minus 2, and then solving for y. So to solve for y, we'd add 2, so we'd get x plus 2 equals negative 1/2 y. So if I times by negative 2, those would cancel, leaving me with y equals negative 2x minus 4, because I can distribute that through. So what does that tell me? That tells me that my inverse here, f of negative 1 of x, is negative 2x minus 4. That's our inverse. Or you could have left it negative 2 times x plus 2, if that helps. Same thing. Okay, so that's all you got to do with those first 7 is you simply take it. Let's look at 5 now. So y equals x squared minus 4x minus 12. Now this part right here has to deal with the domain, because the inverse of a quadratic, remember a quadratic looks like this. Well, if I find the inverse of that, it's going to look like that, and that's not a function because it doesn't pass the vertical line test. So they just tell you to use half of it, so it'll work when you're dealing with it as a function. So let's swap all the x's and y's. Okay, now we're going to have to factor this. So we get okay, so if you look right here, I tried factoring, but that actually won't help us that much, okay, because they won't come out to a way that we can solve it quickly. So what we have to do is first we have to get that x over to the other side. By setting it equal to 0, what we're doing is we're going to make it so that we can use the quadratic formula. Okay, so these ones get kind of crazy when we're talking about these ones. So the quadratic formula is going to be our best bet here. So we want to treat it like this. The number here, that's A. The number here, that's B. And we're going to combine these two together. So that'd be like a negative 12 plus x, because we'd pull a negative 1 out of there. Okay, that whole thing's going to be C. So remember, the quadratic formula is the opposite of B, so positive 4 plus or minus the square root of B squared, so negative 4 squared, minus 4 times A is 1 times C. C is going to be 12 plus x. Yeah. Sorry, it's been a while since I've done this stuff. So we've got minus 12 minus x. We plot a negative 1. No, because we want to make that positive, so it's like we're timesing. Yeah, 12 plus x. So, honestly, don't worry about doing number 6. Okay? This might be just beyond what I wanted it to do for you guys. But I'll show this over 2 times a. Didn't want them quite this complex. So that's 4 plus or minus square root of 4 squared is 16 minus 4 times 12 plus x over 2. And we simplify that further. 4 plus or minus the square root of 16, then that negative 4 we distribute, minus 48 minus 4x over 2. Now I'll simplify that. That would be a negative 32 minus 4x, 4 plus or minus over 2. Then we would see what we can pull out of both of those, which is 4. So it would be square root of 4 over 8 minus x over 2, 4 plus or minus. Since that's multiply, I could pull that out as a 2, so we'd have 4 plus or minus 2 square roots of 8 minus x over 2. Then since we share a 2 up here, those would cancel one of those. So we get 2 plus or minus square root of 8 minus x, which since they wanted us to be where x is greater than or equal to 2, just be 2 plus, not minus, square root of 8 minus x. That would be our inverse. Okay, way too complex for what I want you guys to do. So don't worry about 6. 4 you can do it without doing that trouble. Just subtract the 3 and then take square roots and that kind of stuff. Yeah, that was a little too complex. Okay, now number 7, make it y equals square root of x plus 4. Swap out the x and the y. X equals square root of y plus 4. It's the opposite of square root is squaring. So we get x squared equals y plus 4. Subtract 4. You get y equals x squared minus 4. That's our inverse. Okay? Good enough for those ones. Remember on these guys here, you just plug one into the other one to see if they'll work. So like number 1, take f of g of x. So you go, instead of x, you go 4x minus 3 plus 3 over 4. And simplify. Okay, there's nothing in front of the parentheses, so it's just 4x minus 3 plus 3 over 4. Minus 3 and plus 3, we can eliminate the 3's. We get 4x over 4, eliminate the 4's, we just get with x. And that's what you want to do. And you can just put it back in the other way. Okay, same with 2, 3, and 4. That's the same process. Now, on the tables, remember you just, like number 2, you just rewrite the table. So you go like this, and then you just swap. So that's 3, 4, 5, 6, 7. And on the right side is 2, 3, 5, 9, 17. You just swap the sides. That's all you got to do. Now on the graphing, let's take a look at number 8. There's a few different ways you can think about doing this. Mine would be to find these 3 points, find their coordinates. So that would be negative 4, 1, 1, 0, and 5, negative 2. And then just swap them. So the inverse is going to be the opposite. Negative 2, 5, just like you did with the table. 0, 1, and 1, negative 4. And these are the ones you want to graph. So 1, negative 4 would put me right there. 0, 1 would put me up here. Negative 2, 5 would put me up here. And then you could just graph it that way. And there you go.